Okay, ready.
Yeah. So is there any topic in particular you wanted to go through?
Not in particular, no.
Okay. So we can just do these hardest questions, if you like.
Yeah, that's good. I'll try that.
So tell me if this was worth doing. So the part C one.
Part C. So I can do it now actually. So
Okay.
x squared minus 9 over 4 times 8 over x squared plus 5x.
And if it makes it easier, you can do A and B first, or if you
Okay.
think.
I think I'll be okay. I can because you just factorize the top one and the bottom one, right, for this. So
Yeah.
you have x minus 3 squared in a bracket.
Not quite. Not x minus 3 squared. So you'll have two brackets. One is x minus 3.
1x plus 3, sorry, yeah.
Yeah.
Okay, so, yeah, because it's the difference of 2 squares. Okay, so that can be over 4 times 8 over, and then x squared plus 5x, so that'll be x, so x plus 3 and x plus 2.
Okay.
So we can cross multiply this. So actually, no, I don't. Can we?
How do you multiply fractions?
Oh yes. So we multiply the top, so the numerator. So that would be 8 outside the bracket, and then x plus and minus 3 squared over 4.
Not squared.
Oh, x plus 3 and x minus 3. Yeah.
Yeah.
And then 4 over x plus 3 and x plus 2. So we just divide this, so we can get rid of the 8 and the 4. So we have 2 and then outside the bracket x plus 3, x minus 3 squared over just x plus 3 and x plus 2.
Can you make it even simpler?
Yes, you can, because I noticed there's an x plus 3 on the numerator and the denominator.
Yeah.
So you so 2 and then outside the bracket, so 2 outside the bracket and then x minus 3 over x plus 2. And
So
I think we can simplify this even more. So we have 2x minus 6 over x plus 2. And that would, I don't think, can you simplify that? So,
no.
No, I don't. Okay.
And yeah, so, and this part here is fine because it's good to have it factorized, because that's how we solved this or that's how we simplified this, by factorizing. And so there's nothing wrong with leaving it factorized, because maybe you'll later add it to something and simplify it again or something like that.
Okay, right, okay.
How about if you're adding the fractions, how about question D?
Okay, so I'll just do this now. I just wanted to say before this, I did a test on differentiation.
Oh yeah?
Just last week, and I got 95% in that, which was really good.
Yes.
So, great. So thank you for your help as well with the topic.
No, you're welcome. So which one of these will we do? Let's do C. Let's do question C.
Okay. C would be okay. So 1 over, we'd factorize this first. So 1 over x. Thinking so. Yeah, x plus 2 and x plus 4. 1 over x plus 2, x plus 4. Plus 3 over x squared minus 3x minus 28. We want to factorize the second one, don't we? So that would be 3 over x. X minus 7. 4.
Yeah.
So yeah, so we have 1 over x plus 2 and x plus 4 plus over an x plus 4. Right, so
So I'm just going to close the door 1 sec.
I'm not sure how we'd simplify this further. I don't know how we could.
Sorry about that.
It's fine. But what do we do to simplify this further? I'm not too sure.
How do you add fractions?
We need a common denominator.
Okay, so how could we get a common denominator?
Okay, so if we multiply the first fraction by x plus 2,
Yeah.
so that would have x plus 2 over x plus 4.
Oh, hang on. The first one already has x plus 2 on the bottom. What would be our common denominator?
We'd need x plus 4 as a common denominator.
You would need, I think, 3 brackets in total. So they both have x plus 4. One has x plus 2, one has x minus 7. So what I would do to get your common denominator is I would get the common denominator of x plus 2, x plus 4, and x minus 7.
And x minus 7, okay.
Yeah, and so what would be on the top then?
Okay, so I'll just copy that down to x plus 4. Yeah, so on the top of the first fraction, we'd have x plus 7, x minus 7.
Yeah.
And that would be plus 3 lots of x plus 2.
Mm-hmm.
Which is equal to, so 3x plus 6, 7, so 4x minus 1 over our triple brackets there. So
that's it. And will 4x minus 1 factorize?
4x minus 1. No, you can't, I don't think.
And so that's our final answer. We can't simplify it.
Okay.
Yeah, so in general, to add algebraic fractions, you get a common denominator, same as always. And the way you do that, it's kind of like the cross multiplying. You know, we multiplied by x minus 7 and we multiplied by x plus 2.
Okay.
Any questions there?
No, that's great. Actually, I just wanted one thing. So with questions where there's a double bracket on the bottom, you want to have it so the denominator has to be common to all of the brackets, is it? Something like that?
Yeah. So for this one, we multiplied the top and bottom by x plus 2. And then this one, we multiplied the top and bottom by x minus 7.
Yeah.
And the reason why is to get a common denominator. It's the simplest way to get a common denominator.
Okay.
So just multiply by what you need to multiply by. So this is 3 fractions. It's the same idea. It's a bit silly. This one, we could practice it. Do you want to do one more question like the one we just did, or you think you'd be fine with them?
Could I do one more just to make sure?
Okay. Let me just see. Is there any decent one here? Let's do this one.
Okay. So that is. Okay, so that would be 1 over x plus 3 plus 2. Yeah. So x plus 3 on the bottom, and then x plus 2. Plus 1 over 5 outside the bracket, and then x plus 2 again.
Yep.
So we need the denominator to be like, so it has to be over x plus 3, and then x plus 2, and 5, I think.
Yeah.
So we have to get it to, so we'd have, that would be just 5 plus x plus 3,
Yeah.
which would be x plus 8 over 5, and then x plus 3, x plus 2.
3x plus 2 and yeah, that's it. And so find the value of a. A equals?
So it's just 5 there.
That's it. Any questions there?
No, that's good. Thanks.
Okay, so you've got the idea. Okay, how do we expand third brackets?
Third brackets. So I'm guessing they're pretty much the same as just normal brackets. So I'll just try. Which one did you want me to try?
I think A.
Okay, so A. We have third brackets. So 3 plus root 5, and then 3 minus root 5. So because this is a difference of 2 squares, we can kind of do it a bit quickly. So we have 9 minus 5 here, because root 5 times, so then that would just be 4 as I've expanded. So
that's it. And any idea how you do part E?
Rationalize the denominator. Yeah, so I think you multiply both the numerator and denominator by 7 plus root 2.
We rationalize means make it so it doesn't have a square root. So our one up here, our answer doesn't have a square root.
Yeah.
And so what would we have to multiply 7 plus root 2 by?
7 minus root 2, I think.
Yeah. And so that's what we're multiplying the top and bottom by.
Okay, so 7 minus root 2. And, okay. Which is just 7 minus root 2 over 7, so 49 plus 49. So over 47. 7 minus root 2.
That's it. Any questions there?
No, that's good.
And so to rationalize the denominator, if you have a number plus a third, you do difference of 2 squares.
Yeah.
So what would you multiply by for question D?
Question D. Okay, so we'd use the same sort of principle. So 4 over 1 plus root 6 times 1 minus root 6 over 1 minus root 6.
What would you get?
So that would be 4 minus 4 root 6 over 1 minus 6, which is over minus 5.
Well done. And how about the last one, F?
So that is, you'd have to multiply that by 8 plus root 2, so I'll just do that now. So 8 minus root 2. Which would be, so is that just 6 plus root 2 again? So okay, so we'd kind of have a double bracket on top, which I can expand. So
yeah.
6 plus root 2, and then 8 plus root 2 as well. And that would be over 8 times 8, 64, 64 minus 2 over 62. So then the top thing we will have is just 6 times 8, 48.
So 48, yeah.
Yeah, so the thing on the top we'd have is 48. So that would be 50 plus 14 root 2.
So you're trying to do it in your head. So
yeah.
6 times minus root 2?
Yeah, so then that would be minus 6 root 2. Oh, so, okay. And then plus 8 root 2. And then we just have minus 2 there.
Yeah.
Okay, yeah. So that's a bad mistake. So that would be 46 plus 2 root 2 there.
Yeah. So this is way too difficult to do in your head.
Okay.
Yeah. Any questions there?
No, that's good.
And just a little thing, you can make it simpler. You could half all the numbers here.
Yeah, okay, so that would be 23 plus just root 2 over 31.
Plus root 2 over 31. That's it. Just because sometimes they want you to do that. Okay. Quadratic formula and completing the square. Would you be okay for these?
I think I'll be okay, but could I just try maybe
Sure.
one?
Sure, yeah. Go on, pick one.
So should I try maybe A?
Yeah.
So x squared minus 6x plus 1 is 0. So just x, so 3. X plus 3 and then x minus 2 in the brackets to equal 0. So then x is just minus 3 or x is 2.
No. What is minus 3 times plus 2? So you did it the other way around. You did it as though it was x squared minus 1 plus 6. Minus
Oh, right.
1x plus 6. So this one, you have to use the formula.
Oh, okay, sure. So then that would be minus b plus or minus root of b squared minus 4ac over 2a. And we know our a value is 1, our b value is minus 6, and our c value is also 1. So that would just be 6 plus or minus root of 6 squared minus 4 times 1 times 1 over 2 times 1. So x is, I'll just type that in the calculator. Do they want it, how many, in third form, so that would be x is 3 plus 2 root 2.
Yep.
Or x is, and then, or x is 3 minus 2 root 2.
Yeah, that's it. That's 2 over 2. And then if you half the top and bottom, or half everything, yeah. 3 plus or minus 2 root 2 all over 1, which is the same thing as just by itself.
Yeah.
Do you want to try the completing the square one, or you think it'd be okay?
I think I'll be alright, yeah.
Okay, that's fine. So you're good for that. Let's see. Oh, did I include the thing? Let me just see. Okay, let's solve these.
Okay. So 10A. Do you want me to start with 10A or?
Let's start with B, I think.
Okay. So 1 over x minus 1 plus 1 over x plus 2 is 5. So we want a common denominator between these two. So we'd have x plus 2 over x minus 1 in one bracket and then x plus 2 in another bracket.
Okay.
Plus x minus 1 over x plus 2 in one bracket and then x minus 1 in the second bracket to equal 5.
Okay.
So, okay, so what do we have? So then we can have it, we can so add these two up together. So we have 2x plus 2 minus 1 is just plus, yeah, so 2x plus 1 over, we can expand the bracket, I think. So we'd,
yeah, 2x plus 1 Do we need to expand this bracket? Yeah, we probably do.
Yeah. So to expand it, we'd have x squared plus x minus 2. And that is all equal to 5. So what we want to get this in the ax squared plus bx plus c form. So I'm trying to think what we could do. So yes, so 5 and then in a bracket x squared plus x minus 2 equals 2x plus 1. X squared plus x minus 2 is 2x plus 1. And we just make it all equal to equals. It's all over 5 actually. Sorry.
So I wouldn't go back to having a fraction.
Oh yes. No. Okay. I see this. So it'll be 5x squared plus 5x minus 10.
Yeah.
I think equals 2x plus 1. So we take those two to the other side to have it equal 0. So 5x squared plus 3x minus 9 is 0.
Hold on. So you have to subtract 1 from both sides?
Oh yeah, so minus 11
Yeah.
is 0. So then, do they want us to use the formula, or I think I might use the formula for this.
Yeah, and I think you'd be okay for that, am I right?
Yep, I think that's right.
Yeah, so you just use the formula. How would you do the exam question?
Find the exact solutions of equal to 12. So you have to get that in the ax squared plus bx plus c form. So I'll get a. So then x is 12. So x plus 5 over x minus 12 is 0. Okay, yeah. So basically, I just thought if we want this, if we want to get these kind of on the same level, we can have it over x. So x squared over x plus 5 over x is 12. So
yeah, there might be a simpler way. You want to get rid of the fraction with the x.
Yeah.
What is the opposite of divided by x?
Oh, we just multiply the other side by, so we'd have 12x is x plus 5, and then you can, that would make it a lot easier actually. So x plus 5 is 12x.
You have to multiply everything by x.
Oh yeah, so x squared plus 5 is 12x.
Yeah.
X squared plus 5, plus minus 12x plus 5 is 0. So we can have x in one bracket.
It's probably completing the square or formula.
Yeah.
Sorry, what? If they want exact solutions, if you can't factorize it, you just do formula or complete in the square and leave your answer in the square root.
Okay, right. So if they use find exact solutions.
Yeah. So hang on, if we just go back a second. So this one here, we got 3 plus or minus 2 root 2. So that's an exact solution. And if you wanted the approximate solution, you would put 3 plus 2 root 2 into your calculator and press SD and give it to, 1 decimal place, whatever. And then 3 minus 2 root 2, answer, and SD, same thing.
Okay.
And so, but this is an exact solution. A square root is an exact solution, exact number. You would have done this eventually. You would have gotten here eventually when you got it over a fraction over x. Then you would have multiplied everything by x, and so you would have gotten the same thing.
Yeah.
Any questions there?
No, that's fine. That's good.
Okay, how do we do these?
So these are like kind of f of x questions. So h of x is 3x squared minus 4. H of x plus 7. So would that be 3x minus 4? 3x squared minus 4 but we add 7 to that.
Yeah.
So that would be just 3x squared plus 3.
Yeah. How would it be?
B, so 2hx. Okay, so yeah, we want to multiply the... so is it that 3x squared minus 4 equals 2?
It's not the h of x equals 2, it's 2 the h of x.
2 the h of x. Oh, so just 2 outside of a bracket and then 3x squared minus 4 inside.
Yeah. How about C?
So h2 of x. So so for the x value, we just have 2 of those. So that would be 6x squared minus 4.
And so the way you sub it in is instead of x, you have 2x in a bracket. The 3 is to the left, the squared is to the right, and both are outside.
Okay.
And so what would that get you?
So that gets us 2 times 3, 4. So 4, 3 is 12x squared minus 4.
That's it. 4. And how about the last one?
So h of minus x. So we have, we replace all the x values for minus x. So, but that would be the same, I think, there. So
that's right. So in a bracket, minus x squared, and yeah, you get the same thing. Because a minus squared is the same as a plus squared. Any questions there? Is that one alright?
yeah.
Okay. Okay, composite functions. How do we do A?
Composite. So A, 13A. So we first want to find f of 2.
Mm-hmm.
So f of 2 equals kind of, we sub in 2 for the x. So that would be 6 minus 2 and then 2 in a bracket. So that would just be 2 as our result. And then we want the g of 2 next. So the g of 2 is, so the g is 10 minus x, so 10 minus 2, which is 8.
Was it the g of 2?
G of 6.
I think, did you look at the wrong one?
The g of, question A, is it? Oh no, yeah, I was looking at the wrong question.
I think you looked at 14, yeah.
Yeah, so so that would be x squared plus 7. So that would be 2 squared plus 7, which is 11.
That's it. I think you're fine for those. I think you have got... Okay, so let's now do 14A.
So the g of f of x. So we know the f of x is 6 minus 2x. So we basically replace that into the x value. So that would be 6 minus 2x squared plus 7, which is then 6, 36.
Are we the g of x here?
Sorry, what was that?
So for this one, the f of x is 4x minus 3.
Oh yeah, I was looking at the wrong one again, sorry.
Yeah.
So yeah, so 4x minus 3, and we put that for the 10, for the x value. So that would be 10 minus 4x minus 3, which is 4x minus 13. Or minus 4x minus 13.
So expand the bracket, what do you get?
10, oh sorry, yeah, so minus 40x.
No. It's like if you're just minusing that bracket. So,
yes.
So it's it's like minus 1.
Okay, so that would be that would be 7 minus 4x.
Minus 1 times minus 3.
That's 3, isn't it? So 10 So 13 minus 4. So.
Yeah, it's basically minus 3. And so if it helps, you can think of it as expanding the bracket with a -1.
Okay, yeah.
So it has to be minus everything. So everything in the bracket changes sign. Okay, let's try B.
So the f of g of x. So the g of x is 10 minus x. And we replace that into the 4x minus 3. So 4, and then what is it? 10 minus x. 4 minus 3. It's just, then it's... yeah, so that would be 40 minus 4x minus 3.
Yeah.
Which is 37. 37 minus 4x.
4x, that's it. Let's see. So H. Let's try C. That'll be the last one we do.
Okay. C, what is this? On 14. Yeah?
No, hang on, not that one. D. Let's do D. Yeah, 14D.
Okay, so. Okay, so that is. So f of x is 4x minus 3. And the h of x is x squared plus 7. So 4x minus 3 squared plus 7.
Yeah.
So that is 16x squared minus 24x plus 9 plus 7, which is 16x squared minus 24x plus 16.
Yeah. Any questions there?
That's okay.
Yeah, you've got it. Okay, inverse functions.
Find the inverse. So x is when it says the x and the arrow, is that kind of like the same as f to the -1 of x? Is that?
It's like f of x equals.
Okay. All right. Okay. So f of x is 4x plus 9. So you said a to do, was it?
Yeah.
Okay, so then we can say y equals 4x minus 9 plus 9. So then x is y minus y minus 9 over 4.
Okay.
So f to the -1 of x is just x minus 9 over 4.
X minus 9 over 4. And to put it back into their form, it would just be x and the arrow and then x minus 9 over 4.
Okay.
So they're basically saying x maps to 4 times that number plus 9. And so our x, the inverse function is x maps to x take away 9 divided by 4.
Okay, right.
What would be B? We'll leave it there.
So B, so then I'll use the f of x just to make it a bit simpler for me. So f of x equals x over 3 minus 4. So y equals x over 3 minus 4. So y minus 4. So 3 in a bracket and then y minus 4. So that's inside of a bracket is x. So, and then we can kind of swap it around. So 3x minus 12 is the f of x. So x and the arrow is 3x minus 12.
So divide by 3, then take away 4. In this one, I think it's wrong. If you do the opposite, so you'd have to add 4, wouldn't you?
Yeah, so it will be 3x plus 12.
Add 4. So y plus 4 and then times it by 3. Yeah, that's it. Fine. Any questions there?
That's fine. I got that. That's good.
G inverse F inverse. How would you do D?
Letter D. So F minus. Okay, so F. Okay, so sorry. So F to the minus 1 of A equals. So F to the minus 1 of X, first of all, is just. So I'll write that down. So. 1 of X equals. If we say so, Y equals 4X minus 4. Y plus 4 is 4X. And then X is just Y plus 4 over 4.
Mm-hmm.
And then Y would be X plus 4 over 4. So F to the minus 1 of X is X plus 4 over 4. So, okay, so and then you have to, that's X. So then we have to have G to the minus 1 of X as well. So I'll just grab some more paper if that's okay. I'll be 1 second. Right, okay, so so G to the minus 1 of X. So we have Y equals, what is that? So Y is 4X, 4 and then X, yeah, 4X plus 1. So 4 and then X plus 1, which equals 4X plus 4. So then Y minus 4 is 4X. X is just Y minus 4 over 4, and then Y would be X minus 4 over 4. So we have to get these, so when we add these two values, we get 1.
Mm-hmm.
So, so X plus 4 over 4 plus X minus 4 over 4 is 1. So we can kind of break this down. So X over 4 plus 1 plus X over 4 minus 1 is 1. So that means that 2X over 4 will equal 1 because the 1's kind of cancel out there because we have a plus and a minus 1. So 0.5x is 1. So X would be, you could divide it by half, which is timesing by 2, which is then 2. X equals 2.
That's it. So X equals 2, and we'll check. 2 plus 4, so 6 over 4 plus 2 over 4. Does that give us 1? So that's, I don't think so. 3 over 2 plus a half doesn't give us 1. Something's gone wrong there. Oh, no, hang on. So, yeah, so 2x over 4 equals 1. X equals 2. 6 over 4 is 3 over 2. Oh, yeah, it's minus. That's why. Because 2 minus 4 is minus 2. And so 3 over 2 minus 1 over 2 is 2 over 2, which is 1. That's it. It's correct.
All right, is it? Okay.
Yeah. Any questions there?
No. Okay.
That's fine. We did that one. Okay, let's just do A part 1.
13A1. So in AI. So EQR. A to B is okay. So A to B is I'll write that down. Equals. So we have the coordinates of A. That would be 2, 13, and then we have to minus 5, 22. So we have to get basically 522 minus 2, 13. So that would give us 3, 7, 8, 9. So 3, 9. So that would be, so our column vector for that is, so it's a change in x over change in y. So that would be 3 over 9.
So you would just say, it's just called 3, 9.
Okay. Oh, yeah.
It's not a fraction. And how about AC?
So 8c. Right. So AC is just, what do we have for A? 11, so 1140 minus, what's A? So 213, which would be 927, and as a column vector is just 927.
Yeah. And what is this last part about? Part B.
Part B. So what do the, so I'll show you about points A, B, and C. Well, they're on the same line because they're kind of all they're all proportional. So like it comes to the same ratio of 1 over 3.
Yeah. So basically, what would you have to multiply AB by to get AC?
By 3.
Yeah. And so basically 3AB is equal to AC. And do we have to say anything else? Yes. And they share the same coordinate 522, and so they're on the same straight line.
Okay, right.
Okay. The point P has these coordinates. Show that they're collinear, so we just did that. It's fine. Okay, let's try this.
So which one do you want me to try first?
Let me see. Maybe it's too easy. What would be O to M?
O to M is O to. Yes, that would be O to. Oh, it would just be A.
Just A. And so what is M to O?
M to O is minus A.
And so what is A to B?
A to B. A to B is A to O plus O to B,
Yeah.
which is minus 2A plus 2B, which is just 2B minus 2A.
That's 2A. And I think you are fine there. Hang on. So the answer to B and C show A to B. Sorry, A to B and M to N. Okay. What is M to N?
M to N is half of O to half of A to O. Well, it's actually M to O plus O to N.
Mm-hmm.
So I'll write this down actually. Sorry. So could you give me a second? I just need to copy down this.
Sure.
Yeah, so M to N is just M to O plus O to N. So that is equal to half of A to O plus O to B. Half of A to O plus half of
Mm-hmm.
O to B. So that would be just B minus A.
And the last part, what does your two answers show you about A to B and M to N?
A to B is twice the length of M to N, and so that must mean that the triangle MON is in and it's inside the triangle, so they're congruent triangle.
What does it tell you about the vectors A to B and M to N?
A to B is 2M to N, so
So what two things does a vector have? So a vector has size and direction.
Okay, right.
So one of these is twice as long as the other. And what do you know about their directions?
So their directions are the same.
And how do you call that if two lines have the same direction?
They're parallel.
Yeah, therefore they're parallel. And so that's always true. When you have one vector is just a factor of the other, like, just multiply one by something, by a constant, and you get the other, then the two of them are parallel.
Okay.
And so this one here that we did before, so 3AB equals AC, so those are parallel, but they're not just parallel, they're actually on the exact same line because they pass through the same point. These two don't pass through the same point, and so they're just parallel.
Mm-hmm. Sorry, could you maybe write that down? It might be useful for me to.
I have a better thing for it. So straight line. It's weird. It seems to be. So parallel. Okay, so basically, yeah, if one is a multiple of the other, it's parallel.
Okay.
So I think that one's fine. And then if I just go to the other one, the collinear. Yeah. So if one is a multiple of the other, so that shows that they're parallel. They also pass through the same point Q, and so they're collinear. And so for our one, for our example, we had AB and AC. They're both they were one was a multiple of the other, so they're parallel, and they both pass through the point A because one was AB, one was AC.
Okay.
And so they're what's called collinear. They lie in the same straight line. And so I can paste that into the previous one. Paste it here maybe. Okay, how would we do this one? A to X.
I'll just draw this diagram. So A, B. So A is there, and then X is here. So A to X is just A to O plus O to X, which is A to O plus, and then O to X is just, would that be plus half O to B?
So the point X is in the ratio 1 is to 2.
Oh, right. So that, yeah, I didn't see that. So then that would be 1/3 here, and 2/3.
So let's say A to X is 1/3 of what?
Yeah, so plus 1/3 of A, plus 1/3 of O to B.
No.
Plus 2/3 of O to B.
So I would just start from the beginning. So A to X is 1/3 of what?
Oh, 1/3 of A to B.
Yeah, and that's how I'd go about it.
Oh, yeah, that makes it a lot easier actually. So yeah, so A to X is 1/3 of A to B, which is 1/3 of, so A is, which is just 1/3 of actually minus A plus B.
Yeah.
And we could just have equal to B over 3 minus A over 3.
Okay, I'll leave it as a third B minus
All right.
a third A.
Okay.
And then, so how would you get O to X from that? Or how would you get O to X?
O to X is just O to X, so that would be A to O plus O to X. So
So you have to go from O to X.
okay, yeah, so O to X is it just
because it's part B, in part A we found A to X. Is there any way we can use that answer?
is it, I'm not sure what you'd do for this one, so
So it's literally just O to A and then A to X.
oh yeah, that makes sense. Okay, yeah, so it's okay.
And what did we say A to X was?
We got that as a third of B minus A in a bracket, or you like that, yeah. So
Okay.
O to A is just A, yeah. So that would be, which equals A plus a third of B minus a third of A.
And simplify.
Yeah, which is just a third of B plus 2/3 of A.
That's it. Any questions there?
Oh, I got that. That's good. Thank you.
Yeah, and so it just kind of helps if you can use your previous answer, because it takes a lot of the work out. In terms of A, so that's a midpoint. So I think midpoint are okay. Let's try part A for this one.
Okay. So part A. Vector x, y. So x, y equals xo plus oy. Which is minus 2a minus b plus 4a plus 3b. Which is 2a plus 2b.
Okay, and then part B.
Part B, so expects vector OZ in terms of A and B. So, okay, so we can use our previous answer again. So O to Z
Mm-hmm.
is just, we got X to Y, didn't we?
Mm-hmm.
So, Y plus X to Y, so that is okay. So
And I'd recommend you do this by doing like O to X and then O to Z and then X to Z. So
yeah, yeah. So okay, so yeah, that makes sense. So okay, so O to Z is O to X plus X to Z, which is O to X is well, first, yeah. So sorry, O to X is 2a plus b
mm-hmm.
plus X to Z, which is, well, we know the ratio of this is XY to YZ is 2 to 3.
Mm-hmm.
So, so 2 to 3, that. So the value we got, 2a plus 2b, is just 2/5 of the entirety. So we times that value by 5 to get 5a plus 5b, to get x to x to z. So plus 5a plus 5b.
Hold on. So 2/5. If you multiply it by 5, you'll get 2, so you'll get double it.
Yeah. Yeah, no, because 2/5 is 2a plus 2b, isn't it? So 1/5 is just a plus b.
Okay, yeah. So you multiply it by basically you multiply it by 5 over 2 to get 1.
Yeah, yeah.
5
So,
halves. Yeah.
that's kind of what it. Yeah.
Yeah. Multiply by 5, then divide by 2.
Okay. So yeah, so that would be, to simplify that, we have 7a plus 6b.
That's 10. Half of that is 5. 7. A. Plus 6b, was it?
Yes.
That's it. You got it. Yeah, so this type here, yeah, it's like 5 halves, or however you want to do it. Yeah, any questions there?
No, that's fine.
Okay, and that's good. And maybe I'll just skip the rest of vectors because I think you're good for them for the next time. And that would be the beginning of the next one, would it? No, that's vectors. That's vectors. That's vectors. See, you're good for vectors, just want to say. Okay, send velocity time graphs. Yeah, how was that, Stefan?
That was great, actually. Thank you. I just wanted to ask if you could perhaps email me those like slides. So maybe, because I think I did vectors. We both did them quite a bit of a while ago. So just to refresh my memory, I think it's probably good to do a bit of practice.
Okay. Do you want to continue on for next time? And it looks like, so this is 61 out of 77, and so I think you're nearly finished all the hardest topics.
Okay, that's great. Yeah, we can continue next week.
Okay, maybe I'll just say finish. Any questions for me in general?
No, that's fine actually. But again, thanks for the help with differentiation, because before I didn't really get the topic, but now I really get it. So thank you.
Okay, well done. No, congratulations, you did great. And yeah, look forward to talking again next week.
Yep, speak to you next week. Thank you.